So this complete briefly description of metaprogramming and the macro. Again, is a very powerful features that you can investigate further if you want to go deep in the language. We open here another topic that is how to interface Julia with other languages. So Julia is relatively new. It has less library than other much older languages. However, it is very easy to interface code and libraries written for other languages in Julia, or sometimes you want to do the opposite. As Julia is fast, why not make the URI coding in Python? Why not to use Julia to do something critical where performances are critical? So there are three ways to interface Julia with other languages. At the lower levels, we can interface any language that has a C interface, because you can call, and we will see here, C or Fortran libraries directly from Julia without anything else from Julia base. And this allowed people to write specific interface for other languages. We will see again R and Python, and this interface then are use the C interface, these packages, and user of these packages can write just in Julia code and interface already any kind of packages in R or Python. And because this is so easy to do that, many people already created packages that interface specific Python or R packages. For example, here I make an example of SymPy. Is a package for symbolic computation, and there is a sympy.jl Julia package that interface this SymPy package using pycall. That is, pycall is the specific package to interface Python in Julia, but use in turn the C interface. So at the end you are going to use the C interface, but if you use this sympy.jl package, you don't even need to know that behind there is a package that is not written in Julia. So let's start to see how can we interface C libraries directly in Julia. And for this example to work, you will need to have a C compiler installed in your machine. So first, let's say C header. So in C you divide by the headers and the source. So here is the header of we're going to create two functions, get5 and double my sum, but well, it does what it says, sum two elements. So here is the declaration, and here in the source, in the C source, I'm defining the two functions, and this is C. And what I do, okay, I'm writing these to file, and by the way, this is the way you write some string. So here I open a stream, and the name and with functions that operate on my stream, and this will close the stream automatically. In place of using an anonymous function as here, where I just write on the stream the string. So this is the stream and this is the string. And I can use, instead of here, I can use a do block, and or if I have something longer to do, but here I just have to write one sentence, so I put it here as an anonymous functions. Here you write the name of the file that you want to open, and here you put the flag W for writing. If you wanted to read only, you could have write R. If you wanted to append, you had to use A instead of W. So here I wrote the header, and here I write the source. So another important thing here is how do I run system command. So first I put the command that I want to run. In this case, the command I want to run is gcc, that is the new C compiler that must be installed with these flags that transform the source code and the compiling object code. And so here is the command that I want to run, the first one, and then I have another command that is the linker, so that I have a shared, he put this object code in a shared library. So with these backticks, I use these backticks to define my commands, and here I run the commands. At this time, I should have in my file system this library libmyclib.so. Okay, so this is just how I created. I did nothing else than writing some C code and writing on file and compiled. And notice that I managed to do this all from within Julia. Now I want to use this library. To use this library, I first need to define the place where this library is using a constant. And it must be a full path. So here is the full path of the library, and must be a constant string, because when I call, so this is the function we are going to use. So these functions, here I will call my get5 functions, and here I will call my sum functions, and the argument I need to pass to this C call is a tuple with the name of the function and the library. Then the second parameter of this C call function is the type that is returned by the functions, and then I have another tuple that give the types of the parameters that I call the function in C. And everything else then is the argument of the call. So here I have two arguments, and I have two types. So first and second are two float 32. Here I don't have any argument, but still I need to put a tuple to, even if it is empty. And there is something to say, is the mapping between C types and the Julia type. So here I defined sums. C use integer. If you come here, so the first one is an integer, and here is a double, and here is a float, and here I give the mapping of these three C elements to the corresponding Julia types. And you can use this one, but if you don't want to remember this mapping, you just get the C name and you put a capital S, and these are aliases defined in Julia for the corresponding Julia types that map the C types. So if you don't want to memorize which is the mapping, you just put C integer, C float, C double for everywhere you have in C an integer, a float, or a double. So I call my library, I get the results I do expect. So we move to Python. On Python we have this this standard, I would say, package that is called pycall.jl, that is very nice because it takes care of basically everything. First, it will allow you to install automatically a version of Python for your private to Julia, if you set the environmental variable like this one, or you can put the path of Python in your computer, so you can use the Python version that you already have installed on your systems. And also it will take care of converting Python types and including complex types like arrays, like strings, string, list, and NumPy arrays to the corresponding Julia types. So here I'm using PyCall, and there are several ways. Well, what is this? We saw it few minutes earlier. Well, this is the string macro. So here I have some code in Python, and with this string macro I evaluate this code in Python, and then after that I can call it. I can call this function in many different ways, or I call by evaluating some my args. I create an object function in Python, and I can call directly this Python object, or I can what I'm doing here, I'm doing the same things here, but with the notice that okay, I'm putting arrays, so he understands arrays, but notice that the nth element 1, I think here is putting a 2, is giving me 2. Why is giving me 2? Because Python uses 0 as first element. So attention that here, even if I'm calling this from Julia, and in Julia I would have 1, here I have 2 because Python array starts from 0, so 1 for Python is this element here. And we can also have some interpolated syntax here. So what I did here, what is A? So A was 7 here, and here I'm asking to get the first element, that means the second actually, and is this one, and I get 7. Another alternative is to use PyInclude, and so put everything in a script. So I define some Python code, I write on the disk, and then I include with PyInclude, and I have my function that I put it here with 3 elements available here. Notice here that I have what I did here, so I already have some my arguments with 2 elements. Python doesn't have multiple dispatch, so I can call this function here with 3 elements because I have 3 elements here, but it has not been replaced. So if I now use try to use my sum, my arguments here, I will get an error because this function doesn't exist anymore. It has been replaced, while if I would have been in Julia here, I would have had one version for 2 parameters and another version for 3 parameters. It wouldn't have been replaced. So this is for running code. What if I want to run more frequently, maybe some libraries? I can add a package. If I did, if I'm using my Python installation in the system, I install the package I want from Python itself. If I did install a local private installation of Python for Julia, I can still use this import conda, specifying the modules and the package and the channel to use, and this will be installed in my private installation of Python. Then here I import the code, and I call it a constant. Here this is EZODF is a Python package to manipulate ODF file. So here I just call my document, this is part of the API of EZeta, of this module of Python. And notice that these are Python objects, but I can access the attribute and call the methods with object method as I would have done in Python. I can, for example, append another sheet, so I can do everything very. I am here in Julia, but it's very similar to being directly in Python. There are a few differences where I have to do. For example, I cannot here, if I want to use the API use as index in a tuple. Here I cannot use a tuple to index the sheet, so instead I have to resort to the get function, and but it's the same. So the get function just get the index that I want, and I pass the tuple and I get the Excel, and the same for set value. So no, sorry, this is the normal, this is the API of set value, is the API of EasyZeta. What is different here is that I cannot index here by this string, so I get the object to get the index that I want of this array, and then on this object I call the method set value. Here I don't go opening, but I have a ODS file saved on disk. So this for how to use Python code and Python libraries in Julia. Here is the opposite. Here is the opposite, how to use Julia in Python. And all you have to do, you have to install the Python package PyJulia, and then in the similar way as PyCall install Python, PyJulia install Julia if you are using Python. And I let you read this on the how to do this one on the site. You can run Julia libraries in a similar way that we saw how to do here for Julia to read and evaluate Python code. So you have all this on the website. So let's move on doing the same things for R. The package that you want to use for R is called rcall, and it works in a very similar way, except that if you want to install a private, if you want to force a private the installation of R for Julia, you use the star with the environmental variable rhome instead of an empty string. I don't know why. So let's gonna do that so that we are sure that we run on a empty on a private installation of R specific to Julia using rcall. And similar to the Py string macro, here we have the R string macro where I can evaluate R code here. There is one difference, however, is that here I need, if I am here, I am in Python. If I want to use in R, if I want to use this R object, I cannot just call it like I was doing in Python, but here, okay, I call the R object I call the R object here with Julia object, this 3 and this 4, but the results, to get it back in Julia, I need to use this R copy. This R copy allows me to transfer the output of this function that otherwise would remain as an R object back to a Julia object. Here we are lucky with R, we have no difference for the indexing of array. So here I am transferring this object, this Julia object, this array, to this R object that I obtained by evaluating this R syntax. this R string macro, and I obtain one after I did R copied back to Julia. And sometimes you want an integer, and be sure that because in R all elements are floats, to run in R as integer, as dot integer, and here they get an element. We saw that an alternative to this in Python was to use pyinclude. I didn't find it for R call a similar one, R include. So just let's gonna make it. That's good exercise to make a macro. So we create this macro R include where we pass a file name, and what this macro will do will evaluate will first read the content of the file over a string, and this, by the way, is what you will use to read a file to a string. So if you want to use one line by one line, you have to open and you have to use a red line. But if you are fine to put everything, if it's not too big and stay in memory, and you want to put all in one string, instead of opening the file, you can just use red. So here I have the R code as a string, and then here I use the function reval from rcall package to evaluate my string. So if I, for example, put as R code this again this function with 3 parameters, I write this function to file. So I created this rscript.r but include these functions. I defined here the macro, and I can use this macro to evaluate my file, my file, the code in my file, and here I can call it the function, and I should obtain where I am. I went down my my value here. Again, also for R, this doesn't work because I did replace my 2 parameter function with my 3 parameter function, and I don't have multiple dispatch in R2, so this will not work. Again, I let you study by yourself how to do the opposite, how to use Julia in R. The package that you will want to use in R is called Julia call, and it allows to do the same things as for Python, that is it to evaluate Julia code or to call directly Julia packages. So this for what it concerns R and Python. There are other packages that deal with interfacing other languages, MATLAB, C++, etc. But they all work in a similar way than the 2 that I showed you here.